All right, good morning, everybody. So, just making sure everybody's in the right tutorial. This is DICOM and FHIR. I'm only confused because I see a lot of people. I don't usually see that many people excited about DICOM. So make sure you're in the right room. If you leave now, I'm not going to be offended. It's okay. DICOM is really not that exciting. That being said, we'll give you a quick introduction to DICOM now, just so I understand my audience a little bit better. How many of you know anything about DICOM, have had any experience with traditional DICOM? Okay, this is not bad. So maybe if I make mistakes, you'll actually call me on it today. We'll see. I may have sprinkled a few things in there just to test you out. All right, this is who I am. I work full-time for Agfa Healthcare. I also work with an organization called SIM. And SIM has generously donated a platform for us to do some exercises with. What we're going to do is we're going to go through the presentation. If we have time, we will do the exercises together. But if we don't, the exercises are on the website. Feel free to go try them out. I will be at the imaging table. Oh, I don't like the fact that it keeps advancing. All right, let's see. I will be at the imaging table, so feel free to drop by. Now, the one thing to watch out for these exercises is they use a generic API key. That generic API key is only valid up until tomorrow. After tomorrow, you will have to get your own API key. They do not cost any money. I can show you how to get one, but it's just they like to keep track of who's using the platform, what kind of usage they're making with it. All right? At any time you have questions, feel free to interrupt. You don't have to wait until the very end, okay? Thumbs up? Awesome. I don't think the clicker is working. That's okay. Nope. Computer says no. All right. The slides I stole from Brad, who would have loved to be here, but he wasn't able to. He's an awesome guy, as you could see by the long list of things that he does. I have no idea how he has time for any of these things, but he is on a few work groups. One of them is work group 20, which is the intersection between the FHIR community and the DICOM community. And we also have to thank all these people who have contributed one way or another. So Elliot Silver is Brad's co-chair of that work group that we just talked about. Of course, HL7 International, the FHIR community, you're awesome. DICOM, NEMA is the body behind DICOM, so kind of like HL7 and FHIR. And of course, SIM, as I said, they donated the infrastructure that we're going to be using for these exercises. All right, we'll start with what is imaging? Okay, it's a lot of things really. Imaging is a very loose word. So it can be, diagnostic imaging. You're checking if this patient has cancer. It can be procedural imaging. You're planning how to install some orthopedic things in the patient's body. Oops, they advanced way too fast. There we go. Evidence imaging, you're actually, taking evidence of a wound or something. And of course, last but not least, maybe you're putting images into the report. So all of that is still imaging. And of course, imaging, a lot of people tend to think of it as radiology, but that's old-fashioned thinking. Imaging is much more than just radiology. We live now in an age where enterprise imaging is really the buzzword around the corner. And enterprise imaging means any image captured in healthcare settings should be part of the patient's record. So dermatology images, the patient has a rash that's captured, pathology, et cetera, all of these things should be stored and tracked. But of course, properly stored. It's not just a file, it has to be linked to the patient's record, and that's the trick. This is where DICOM comes in pretty useful. Of course, we talked about the case of having images within reports, and some of you may wonder why. Well, it's exactly because a picture is worth 1,000 words. So you may have a report, and sure, the report tells the clinician a lot of things, but when they see that image, the broken bone or the nodule for cancer, it just means that much more. Of course, they're not trained to read images the way radiologists do, but nonetheless, they can still make some sense out of it. All right? Of course, the other problem that's a common problem with imaging, even though we're in 2018 now, is sharing images. So, you did imaging at one facility, and then a year later you go to another facility, they don't have your images. Now you have to be re-examined, it wastes time, it wastes resources. You've got a risk of radiation, so on and so forth. If you're, let's say, for example, disabled, you have a caregiver with you, well, they have to take time off work, and this is stressful to them, so on and so forth. Needless to say, it's very important that we make this work so that your health record and your images are with you everywhere you go. And when I say that, I'm not talking about a CD. Again, 2018, right? This should be seamless, should be all electronic. So this is one of the areas that we're going to be talking about today. Just a quick recap. A typical imaging workflow looks like this, right? You're admitted to the hospital, they create an order, the order is processed, your image is acquired, radiologist reads it, provides a report, and then that report is distributed around. So besides that, though, we have to keep in mind that we're also living in a new age where beyond just that usual workflow, you've got, patients now expect to have access to their images. A lot of hospitals provide portals where you can log in, see your own images, plus reports, etc. The physicians are also not the same as before. They're not always just sitting at a computer and looking for images. They may be running around the hospital with tablets, looking at images, right, as they attend to patient after patient after patient. Also, computing power has tremendously increased here. We've got servers that can crunch a lot more math problems, images, etc. Access to the internet is a lot more ubiquitous, it's faster, so you're also able to do more. And all of that stuff can also be facilitated with that unique relationship between FHIR and DICOM. Again, DICOM is imaging. Any image should be, in theory, captured within DICOM, whether it's your typical X-ray or if it's your rash or something else. All right. Now, hierarchy is important to understand. So we start with the patient. Patient has a number of studies. Okay, so study is when, let's say, for example, they want to check if, let's say, you have cancer. Okay, so a study is created. Within the study, you have a series. So a series may be, sometimes you may need a procedure where it's multiple modalities. They maybe need to do a little bit of an X-ray along with the CT. So these are series within the study. And then within the series, you have the instances, which are the actual images. How many of you here have actually seen DICOM images in real life? Great. Why are you guys here? You don't need to hear me talk. Anyway, so for example, with an X-ray, it's a single image usually, or like a few, but you're looking at them one at a time. With a CT, they're usually stacked, so you play them pretty much like movie style, but they're actually individual images. So that's the reason why you could have multiple instances in a study, or sorry, in a series. At each level, there is metadata stored in DICOM to go along with this. And again, this is one of the reasons why you have DICOM versus just say, stored as a JPEG file, because it always keeps the metadata. Well, someone says, hey, but my JPEG keeps metadata. It has the latitude and longitude of where I took it. That is correct, but this is a whole different level of metadata that DICOM is built to store, much more. So these are just some examples here, things like study, unique identifier, data study, modality at the series level, and at the instance level. But of course, DICOM also stores even things like, for example, if they're doing slice imaging, it actually keeps track of the exact location of a slice within a patient's body, which is why when you use a DICOM viewer, it's able to show you, the relationship of an image to the patient's body, where their head is, where their posterior and anterior, and so on and so on and so forth. All right, so yeah, we covered everything there. So how do these two actually work together, DICOM and FHIR? Well, you've got all kinds of data over there, which really make up the health record. So HL7, whether classic HL7 or new FHIR, that's usually clinical information, allergies, reports, etc. DICOM has all your images, and then you may also have just simple plain documents, PDFs, clinical documents, etc. All of that stuff comes together and makes your health record. But then how do you know which one is which? So when you're interested in clinical information, you go to FHIR. But when you're interested in imaging, you go to DICOM. I know that sounds easier on the slide than it is in real life. But if you think about it this way, if you're in a hospital and you're trying to find your audience, okay? Are you working with a general doctor or a clinician, If yes, they're probably more interested in the FHIR data. But if you're working with somebody like a radiologist, they're probably more interested in the DICOM data. My background is actually in desktop integration, so synchronization between multiple applications. And this is probably one of the most obvious ones where you see the difference. A radiologist uses PACS to drive the entire workflow. Everybody else in the hospital will probably use the EMR, EHR to drive the workflow, right? They will only click to see images when they want them. So that's typically the difference. Is that clear for everybody? Very good. All right, Brad put a shout out there to the work group. So again, this is a joint work group between the two bodies, between HL7 and DICOM. The two co-chairs, as I mentioned earlier, oops, way too fast, Brad. I don't know why he puts a timer on his slides. You've got Elliot Silver and you've got Brad Jenner. I don't know how this worked, but both of them are Canadian. Shouldn't that be illegal or something? All right, so a common question we get, especially in a conference like this where people may not necessarily know about imaging, why can't I just put it in FHIR? Why do we need DICOM? Someone actually even once asked us, when are we going to put DICOM out of its misery? And I agree about the misery part, but the putting out part is a little too extreme. If you read the slides, I'm not going to read them, the reality is DICOM 1 has been there for a very, very long time. You can't just easily retire it. In fact, if you look at the evolution of DICOM, so going from DICOM to DICOMweb, DICOMweb didn't go back to the drawing board like FHIR did, right? DICOMweb is actually backwards compatible with DICOM. It's built on top of it. So it's an evolution, not a revolution, because you cannot actually afford to do that with DICOM. You can't just say, hey, all that information, garbage, we start new. Patients' records, images have to be accessible for pretty much a lifetime. Of course, there are more specific rules, but I mean, you could basically go back and crack open a DICOM file from 30 years ago, and it'll probably just open up just fine and display without an issue. The standard evolves, but it has to maintain some level of backwards compatibility. That's one of the reasons. The other thing is DICOM, of course, also defines much more than just how you store images. It's a standard for storing, transmitting, displaying, even printing images. It's very wholesome in that regard. And again, it's not just a JPEG file with a bunch of tags. There's a lot more to it. All right, is that clear so far? So I'm sorry, DICOM's not going anywhere, unfortunately. All right, within FHIR, usually your gateway to DICOM is the imaging study resource. So if we, once again, familiarize ourselves with the typical workflow. Now, I do apologize. This one slide is slightly reversed, but Brad did it for a reason. Really, what matters is, so he reversed the bottom row. But anyway, imaging study is the long story short of what we want to do. So in FHIR, you've got all these resources that represent the different pieces of the workflow, and then imaging study is that link between the rest of the patient record and their images. Oops. Okay, this is what it looks like. So if you remember, again, the hierarchy we talked about, you got a patient, you got study, series, and then images. So this is what it looks like. So there's an imaging study resource. I'm not going to go through the details, but then, of course, it could link to series, which then could link to instances. One of the things people find confusing with DICOM is when you refer to that last part of the hierarchy. Sometimes you hear people calling it images, sometimes you hear people calling it instances. It, of course, depends. In a simplistic manner, you could just call it images. But in real life, they are instances because they may actually just be simple objects with metadata. They're not actually displayable objects, but they just provide you with extra information. One prime example of this is something called key object selection document. Ignore the fancy name. The function is actually very simple. Let's say I have a stack of images. I have 100 images of CT, okay, and I want to be able to choose one that I think is representative of, way too fast, representative of whatever observation I made. Oh yeah, this is the cancer right here. So you choose that, and then the PACS will generate a key object selection document, and all that document does is just tell them that this is the most important image in this entire study. So that's one example, but you may also have other metadata objects. Another one is GSPS, and I'm not going to bother you with what it stands for because it doesn't mean much, but basically GSPS is a way of adjusting the image so it displays the most optimally. So things like brightness, contrast, zoom, etc. Even measurements, you could actually leave annotations. And another fact some people may or may not know about DICOM is the measurements are never burnt into the image. They're never stored in pixels. They're always stored as vectors. The two are separate. All right, so let's work with an example. So here you've got a FHIR server. You go and ask it for imaging studies for patient John Doe as an example. And then the FHIR server responds saying, well, there you go, you've got these. Okay, and for each one, it will give you an endpoint. Simple, typical FHIR use case, I think. All right, that's what it looks like. Don't bother reading it, but just to give you an idea, you know, it's your typical FHIR resource in that sense. I'm not going to go through all of these in detail, but we'll just point out a couple of quick things. Oops, again, it advanced too fast. So at the very top, you've got a unique identifier that could be something like a DICOM study OID, could be an accession number, or could just be something completely random. It's not actually required. Obviously, there's a patient reference to link it back to the right record. It will tell you what modalities are in that study. The context will tell you, if this came from an encounter, a visit, etc. Let's see what else is interesting. One interesting one is the endpoint attribute. That tells you where you can get that study from. So, that's where you go. Enough with the talking. I want images.
Is that
endpoint.
Is that in a DICOM format, the endpoint, or is it a FHIR endpoint?
It's a DICOM endpoint. I'll show you that in just a moment. Okay. Over here we have, let me see if there's anything else. Okay, so we'll skip the rest. The slides will be there if you ever want to look at them. Now we go to the series part. In the series part, again, some of these attributes repeat. So one of them, for example, you see is the endpoint, which again is a retrieval location. So then here becomes a choice of whether you want to say retrieve the entire study or maybe you just want to retrieve the series. And again, to give you a more real life-like example, one series could be the X-ray, and then the other series could be the CT. So maybe you're only interested in the X-ray, you could just go and retrieve that. You don't have to retrieve the whole study. To your question, and the slides again advance very quickly, this is what an endpoint looked like. So you could have multiple endpoints for a study, but each one has a meaning. So the very first one says DICOM WADO URI. That's the original WADO standard. So this is the very first standard that DICOM released, I think, in the early 2000s for web-based access. Okay. Then next is WADO RS, and again, don't get the two confused. There's WADO URI, there's WADO RS. The two are different. RS is the newer one, recently released, and it's completely RESTful. So very similar to FHIR. Next one is DICOM Kido RS, and this is a query for metadata, not an actual retrieval. So if you just want to find out a little bit more information about the study, you could use that. And the last one is IHEIID. This would be a URL where you could just launch into a viewer and it would show that study. Yeah, go ahead.
Sorry, as your slides were a little bit too quick, I had a question regarding the instance level. So in that part, can you go back to the slide where you had the definition? Thank you. So there you have a unique identifier, but what I see as an instance is if I have a multi-frame, it is a single instance. So how can I identify that it is frame 20 out of the 65 of this particular image?
That's a very good question. And actually what I would do is I wouldn't even use FHIR for that. I'm going to be very, very honest. In my experience, I've seen imaging study resources, but I don't usually see people actually bothering to create series and instance level resources in FHIR, because you could just go get it from the DICOM, and personally I think that's a more efficient way of doing it. They are there if you want to publish extra information to FHIR, just provide that information. But I would personally just go to the DICOM, because in this case it's the ultimate source of truth. It knows that stuff a lot better than the FHIR stuff does. I would just go to DICOM and get it.
Okay.
Okay, there's another question right behind you.
You said that that's the most efficient way. Would you say that's the most efficient when you're doing research over a large series of images as well?
I think it depends on the kind of research. I mean, are you doing more clinical?
Machine learning.
Yeah, but like, are you actually crunching the metadata or are you crunching the images?
Potentially both.
Okay, it really just depends, right? It could be anything. But again, at the end of the day, once you've gotten to the study part, the reality is the rest of it is really owned by DICOM. As I said, it's the ultimate source of truth, so I probably would go to it, even if I can find the information in FHIR. Unless you have a really good reason not to, you know, like the DICOM service is super slow, or it's behind a firewall, you can't reach it, etc. You know what I mean? It's just, it's a specialty thing. Okay, any other questions? Oh, go ahead.
Does the standard also provide a way to convert it convert the DICOM image to JPEG for previewing purposes?
Yeah, and we're going to look at that. Yeah.
Sorry.
I've got you covered, don't worry. Yeah?
In digital pathology, where DICOM is not yet so much used, a lot of times it happens that you don't have DICOM at all. You're storing images natively in a different format. So
Yeah.
in this case, would it be okay to just have an endpoint that launches the viewer and store all the metadata in FHIR, but not have actually anything DICOM?
I think yes, but I don't actually have very much experience with that yet. I mean, I could answer the question in many different ways. One of the ways is they're, of course, trying to slowly standardize this so that it can go into DICOM. But of course, until we get there, we have to deal with the reality that, yes, most of them are in proprietary formats right now. So I would imagine that you probably could just do what you suggested. You could just stuff it into an imaging study and then have an endpoint, which is the IHE IID that just takes you to the viewer right away. Yeah. Okay, any other questions before we move on? Okay, very good. It's good to know that everybody's awake. So let's take some real world use cases. Sorry for the gross image, but of course, one of the things you could do is you could go to the FHIR imaging study resource, you discover what imaging records you have, and then of course you could use DICOM to go and retrieve the image to show them. And this could be either an actual, full-size image, or it could just be a little thumbnail, right? And again, the example here shows you an image that would have been captured with a normal camera, which is a good example of realistic life scenario, real life scenario, but of course also not necessarily representative. Because the other thing is, one of the questions people ask of DICOM, again, why couldn't it just be stored in JPEG? Well, because those images that are captured in DICOM may not always be 8-bit images, like, every other camera device, like your phone and whatnot. A lot of the time, these images are actually captured in 12 bits or even 16 bits. So it's really nice that you preserve that fidelity and then be able to show it. And of course, there are other things too that go into play. I'm not going to bore you with all the technical details, but there's a lot more to those binary images than just pixels. If it was pixels, it would have been an easy problem to solve, and we probably would have never needed DICOM. Of course, the other one I mentioned is, as Brad says on his slides right here, this could be a slippery slope that you could just request the JPEGs, the rendered JPEGs, and assume that if you just put them all on screen, you're done. The reality is it depends on your target audience. Like if the target audience just wants a basic reference, it's probably good enough. But if your target audience is savvy enough that they'll want to work with the image, that you probably want to launch it in an actual DICOM viewer, whether web-based or thick client. But then then you can actually interact with the image. You can make measurements. You could change, for simplicity, I call it brightness and contrast. But in DICOM, you probably would be shot if you called it brightness and contrast. It's called window level and window width. So just keep that in mind. People are very sensitive about these things. Of course, we also talked about things like GSPS, so annotations that maybe another clinician created, but you need to be able to see on top of the image. Of course, viewers are also now becoming more and more advanced where they could do 3D. They can actually stack the images, and now you can work with it like a 3D object. So there's an advantage to using a real viewer at times. All depends on your target audience. Okay, so here we have an example. I know it's very hard to read, but bear with me. So let's pretend we made this imaging study call. So that would return a few pieces of information that are useful. So it will tell us I'll just show the lines here. So that will tell us things like the UID, the endpoint for the WADO service, which then we could formulate together. Now, sometimes the endpoint is it's a ready-made URL. You could just take it as is and use it. Sometimes you may need to build it, right? Let's say you're dealing with a FHIR server where they populated imaging studies, but they didn't actually bother populating endpoints. So then, you can build the URL yourself, because as you can see, it's a RESTful service. You basically just stick the IDs in it, the references, and you've got what you need. I'll keep this on the screen for you guys. Okay? So in this case, if you look at the URL, so server.com/wado/studies, and then first is the study identifier, and then goes /series, the series identifier, /instances, and then the actual instance identifier. Then we tell it /rendered, that means I don't want the DICOM object, I want a rendered object. In this case, I'm asking for JPEG. And then viewport is the size. So 50 by 50 pixels. I'm looking for a thumbnail. And you send an HTTP header with it that says accept image JPEG. That tells it that you want it in JPEG. You could also ask for it in, say, PNG, for example. Okay? Of course, again, you got to be careful with these things. Not only sometimes the JPEG image is not sufficient, but of course, what happens if you have a stack of images, right? So, actually, before we cover the images, of course, your typical caveats with any API, authentication, authorization, firewalls. But if you go back to the stack example, so if you just basically look at the list of images and make an assumption that I'll take the first one or I'll take the last one, you could end up with this. In this case, the last image doesn't actually mean anything. It's not clinically relevant, right? What maybe you want is that one instead. And for that, DICOM actually just recently updated the standard. You can actually make a thumbnail call. So if you look at the call behind me, it says /thumbnail at the end. So that's basically when you're telling the server that I want a representative thumbnail for this study. Pick one and give it to me. And it would do that for you. Of course, before you all get excited, because I see a lot of nods, people are like, yeah, not everybody implemented this yet. It's pretty new, but it is coming. Okay?
And will that be the thumbnail of the key whatever picture?
Yeah, if you repeat it.
Is that the thumbnail that you're getting back? Is that the key picture that was chosen?
That's a very good question. I don't have a clear answer for you, because what happens is the standard just talks about providing a relevant thumbnail, but it doesn't necessarily go into full details of how you determine that relevant thumbnail. So it will actually depend on the implementation. It's up to everybody to implement it their own way, because of course there are complications. What if you don't have a key object in the first place? Then you have to have some kind of logic to decide what's relevant. What if you have multiple key objects? How do you know which one is the right one? Right? Because maybe physician A decided this is the most relevant image, but then physician B came in and like, no, it's the one next to it. It just really depends. So unfortunately, it's not a clear answer there, but hey, whatever they provide will still be better than just randomly choosing one, right? They'll have some reason for choosing an image. Okay, we also talked about image enabling reports. So Brad has got a nice little nifty example here for you. I'll just load it up. So here you're talking to FHIR. You can just go and look up a report the patient has, and then you can just go and ask DICOMweb, hey, give me some image, and you can just manually embed that image into the report. And hopefully you have some really happy clinicians that will thank you, I'm sure. Okay, here's another interesting use case. Of course, this one is a little futuristic and, use your imagination here, but don't think too much about the Google Glass part of it. Think about your actual technologist in a hospital, right? The person who's running that X-ray room. In front of them, they have their work list, right? In this case, this is a DICOM-driven workflow because that's what the capture usually is. But imagine if you're able to connect their work list with FHIR to bring in additional information, something as simple as the patient's picture. So when they go to the waiting room, they know who they're looking for. That's one thing. You could bring in things like allergies, known symptoms, etc., right? Or a little bit of patient history. So again, it's all about the synergies between these two standards, right? If you're DICOM driven, you could still make use of that information you can get from FHIR, and vice versa. If you're FHIR driven, you could still make use of those images. All right, so this one, again, he's basically just summarizing. So, you know, in FHIR, you have a lot of useful information, things like disease, conditions, lab results, and the reports. DICOM gives you the images as well as metadata. Sometimes you've got metadata in the DICOM that's stored that's much, much richer than what's in the FHIR. Actually, I shouldn't say sometimes. Most of the time, if not all the time, it is. It all depends on how deep into the metadata you need to get, though. Okay, questions before I move on to the next thing? How are we doing on time? Okay, coming up pretty quick. Okay, a couple of things to keep in mind. Brad always likes to put some updates on new standards. So there's a new one called Web Image Capture. It's a standard for being able to capture images through web interfaces. It's pretty useful because, believe it or not, nowadays in a lot of hospitals, they actually do use phones or iPads to take pictures of patients, you know, open wound or stitches or rash. So we don't really have a good standardized way right now until this standard is coming out to do that. Vendors have different implementations, but nothing very specific. You also have web image access, used to be called MHDI. Think of it as XDSI, but a little bit modernized. So it's not all SOAPy, it's more RESTful. So that would be really nice. Remote imaging reading workflow. So this is for radiology practices where you may have, you know, radiologists covering around the clock. So they may have, you know, offices in different parts of the country or, you know, different continents, et cetera. So this is a nice protocol for running that workflow. And invoke image display, we quickly touched on that one. So that one is basically a simple standard for allowing a URL that could just launch a viewer given a study or a patient. Just simple as that. So you don't have to fiddle with it. And because it's a standard, if you have a viewer that supports it, it's the same syntax across the board. So that makes it predictable, repeatable. Does that make sense? Okay. All right, let's wrap it up. And if we still have time, we may actually do the exercises. So again, I'm hoping that's clearer for you now which one to turn to when you need information. Again, it's not that you have to choose either this or that. You know, marrying the data between the two, it's a great thing, but of course depends on your needs. Remember, DICOM is backward compatible, forward thinking. This is not trademarked, by the way, but Brad did make that one up. So again, backward compatible means even though it's a modern API, RESTful base, it still is usable with old data. So if the patient was scanned in year 2000, you can still retrieve their data, you can still display it using modern DICOMweb. All right. Some information. This is where you can go find more information on DICOM. If you Google this, you probably will find it just as quickly too. One thing I found very, very funny is I usually have people who are interested in DICOM say, I'm going to go and read the standard. That's usually a very smart move with most standards, just not the DICOM standard. I can't even remember how many thousand pages it is at this point. And of course, a lot of it is antiquated because a lot of it is backwards compatible. So you got to be very pragmatic with the DICOM standard. You just read the parts that you need to read. Now, the good news is to learn DICOMweb, you do not need to read the standard. There are very easy resources, like the second link up there, that will very quickly teach you with examples on how you could do this. All right? And the one page that they took from the FHIR community is a cheat sheet. So they also have that on the website, that same website. This will help you very quickly figure out, you know, how do I make this request and, you know, what do I need to send, that kind of thing. Makes it pretty easy. All right. Brad would, of course, like to invite any of you who are interested to join any of the work groups that may spark your interest. I'll have a longer listing for you, but of course the most prominent one is Working Group 20, again shared between FHIR and DICOM. To join, you don't actually have to do much. It's really just being on the calls. And if you're not comfortable saying anything, don't. You could just listen. You're not obligated to do anything. There's no homework. There are no quizzes, no expectations. You just enjoy yourself and chat with some friendly, smart people. All right. There's a long list of working groups, but of course he points out two. So again, working group 20, the intersection between FHIR and DICOM. Working group 27, web technology for DICOM. So they are the ones behind things like DICOMweb. All right. And of course, just a quick word about SIM, just to let you know what they are. So SIM stands for Society for Imaging Informatics in Medicine. It's an interesting organization that puts out an annual conference every year in the United States. It's an interesting conference because you get a mix of people from developers to IT people all the way to doctors, and lots of them really. So SIM has also decided to be spearheading the adoption of things like FHIR and DICOMweb in the industry. That's one of the reasons why they have an infrastructure in the cloud running 24/7, 365 that allows people to play with. Another thing they've done, they've actually invested the time and resources to build a cohesive data set. So for example, right now when you use FHIR, a lot of you will use something like Cynthia to generate data sets. What SIM has done, they've taken a different approach. They actually created a data set with real doctors. So they created fictional characters. It's not a big data set, it's only 5 patients, but it's a fictional, believable narratives. So they represent real life scenarios that you find, and it also marries FHIR and DICOMweb. So you got these patients, they'll have things like conditions, allergies, etc. But they also have imaging studies that correspond to the narrative, like, oh, this patient has had cancer. Well, here's the imaging study, right? And of course, patients of different genders, so like male versus female, and the females have mammograms, etc. Okay? So I encourage you to check it out. Like I said, the exercises will expose you to some of that, but by all means, feel free to explore a bit more about SIM and see if it sparks your interest. How are we doing for time?
We have about 2 minutes.
2 minutes? Okay, so again, exercises, but I will skip them. They are on the website. Feel free to do them on your own. If you need help, I'll be at the imaging table. Just come and see me. And with that, we'll open it up for questions. Any other questions? Any concerns?
Hello, I have 2 questions. So first of all, the imaging study resource and the series has both the endpoint definition. Could you explain why the instance itself has no endpoint?
I wasn't really involved in discussions when they decided to have it or not have it, to be honest, but I could imagine that it's just too verbose, too much information. Because, I gave examples of 100 slices, but the reality is usually you're dealing with a lot more. A CT scan with a modern machine is easily 1,000, 2,000 slices. To store an endpoint for each and every single one of them, I think it's just a little too much.
Okay.
Yeah.
And the second question, in DSDO2, there was a image object selection resource in FHIR defined, which was the representation of the cos object.
Yeah.
This was removed in the newer standard. Could you explain some background and what is, from your understanding, the correct representation of the cos object in FHIR?
To be honest, I don't actually have a lot of experience with that resource. Neither was I involved in the discussions when they put it or removed it. But again, if I had to speculate, my guess is it's just redundant information. They probably maybe just ran into a dead end with that road and decided, you know what, leave it for DICOM, maybe? I don't really know. I know cos objects are generally pretty complicated, and it's one of those random objects in DICOM that are used for a lot of weird things. I gave a simple example of just choosing the right image, and that's the common example, but sometimes they're just used for completely random things.
Okay.
Yeah.
Question about genetic information. That's also stored in DICOM, I thought.
Genetic information? I have not encountered it in DICOM, to be honest with you. Maybe it's something new that they started doing, but I've not seen it myself. Not with real world experience.
Okay.
Hi, just a question about de-identification. In terms of making DICOM images available for research use,
Yeah.
what kind of tools have you used or would you recommend for image de-identification?
Image de-identification is a very, very wide topic and relatively complicated. The good news is there are tools. The bad news is none of them are perfect. A lot of things are done sometimes that are weird, because it's not just scrubbing the data in DICOM, which by itself is a problem, believe it or not, because sometimes de-identifying the data may actually break the consistency of the data. So that's one. Two, one of the common problems is, for example, if you've ever seen an ultrasound image, they usually have patient demographics burnt into the pixels. So then you need a tool that could do all of that. The best I've seen, most comprehensive, is a tool called DICOM Cleaner by David Clooney, which I highly recommend. It's Java-based, which is also portable, so you could run it on any platform. But definitely there are a lot of other tools. It just depends on how deep you want to go with scrubbing the data versus how shallow you want to go.
Thanks.
No problem.
That's all the time we have. Thank you.
Have a good day.